Hello, this is DVKT Math. Welcome to my first video on YouTube. In this video, I'm gonna show you how to find the modulus of gamma of I. Here I is the imaginary unit, square root of -1. So I'm gonna get back to the Latex codes to type some equations. And first we're gonna use a property of the gamma function, which is gamma of z times gamma of 1 minus z equals pi over sine of pi z. Okay, so gamma of z times gamma of 1 minus z equals pi over sine of pi z. And then if we substitute z equals I, we would get gamma of I times gamma of 1 minus I equals pi over sine of I pi. So gamma of I times gamma of 1 minus I equals pi over sine of I pi. And next we're gonna use a formula that sine of Ix equals I times hyperbolic sine of x. PDF. Alright, so sine of Ix equals I times hyperbolic sine of x. Or it's also called sinh, or I think it's just me who's calling it as sinh, but I usually call hyperbolic sine as sinh because I read somewhere that it's called sinh, like how hyperbolic cosine is cosh, because C-O-S-H, cosh, so sinh. So I'm gonna call it sinh because I like it better because it's shorter. So sine of Ix equals I times sinh x, and then so we have sine of I pi equals I times sinh pi. And then if we substitute that into the last equation that we got, we would get, I'm going to copy and paste the last equation. So the last equation that we got is gamma of I times gamma of 1 minus I equals pi over sine of I pi. And we know that sine of I pi is equal to I times sinh pi. Sinh is hyperbolic sine. I just prefer calling it as sinh. Alright, so gamma of I times gamma of 1 minus I equals I times sinh pi. And then next we're gonna use another property of the gamma function, which is gamma of z plus 1 equals z times gamma z. So gamma of z plus 1 equals z times gamma z. And then we can think of gamma of 1 minus I as gamma of negative I plus 1. So gamma of 1 minus I is negative I times gamma of negative I. And then we're gonna substitute that into the last equation that we got, which is gamma of I times gamma of 1 minus I equals pi over I times sinh pi. We're gonna substitute gamma of 1 minus I equals negative I times gamma of negative I. So gamma of 1 minus I equals negative I times gamma of negative I. So then we get negative I times gamma I times gamma of negative I equals pi over I times sinh pi. And then we will multiply both sides by I. And on the left hand side, we have I times negative I, which is negative I squared. And I is the square root of -1, so I squared is -1. So the negative I squared is negative of -1, which is 1. And on the right hand side, we have I divided by I, which is 1. So then we would get gamma of I times gamma of negative I equals pi over sinh pi. Alright, so gamma of I times gamma of negative I equals pi over sinh pi. And now we're gonna take the modulus of both sides. The modulus of the left hand side, the modulus of gamma of I times gamma of negative I is equal to the modulus of gamma of I times the modulus of gamma of negative I. And on the right hand side, we have the modulus of pi over sinh pi. It's just pi over sinh pi because pi over sinh pi is a positive real number. So then after taking the modulus of both sides, I'm going to copy and paste the last equation first. Alright, so the modulus of gamma of I, times the modulus of gamma of negative I times the modulus of gamma of negative I, equals pi over sinh pi. Alright, so the modulus of gamma of I times the modulus of gamma of negative I equals pi over sinh pi. And here we're gonna use the complex conjugate property of the gamma function. So here negative I is the conjugate of I. And first let me write down the complex conjugate property of the gamma function, which states that gamma of conjugate of z equals the conjugate of gamma of z. Alright. Gamma of conjugate of z equals the conjugate of gamma of z. Alright, so now negative I is the conjugate of I. So gamma of negative I is the gamma of the conjugate of I. And gamma of conjugate of I is equal to the conjugate of gamma of I. So gamma of negative I is the conjugate of gamma of I. And we're going to substitute that into the last equation that we got. I'm going to copy and paste first. So gamma of negative I is the conjugate of gamma of I. Conjugate of gamma of I. Alright. Oops, I made some mistake. Okay, here we go. So gamma of negative I is gamma of the conjugate of I, which is equal to the conjugate of gamma of I. So we get the modulus of gamma of I times the modulus of the conjugate of gamma of I equals pi over sinh pi. And then we're going to use the property of the complex conjugate that the conjugate of the modulus of the conjugate of z, of a complex number z, is equal to the modulus of z. The modulus of the modulus of the conjugate of z is equal to the modulus of z. So the modulus of the conjugate of gamma of I is equal to the modulus of gamma of I. Then we would get, since the modulus of the conjugate of gamma of I is equal to the modulus of gamma of I, we get this PDF. We get the modulus of gamma of I squared is equal to pi over sinh pi. And now to get the final answer, we just need to square root both sides. And then we would get our final answer is the modulus of gamma of I is equal to the modulus of gamma of I is equal to the square root of pi over sin pi. And this is our final answer for the modulus of gamma of I. If you like my content, please subscribe to my YouTube channel and please also follow my Instagram page. I have an Instagram page, an Instagram math page with the same name, DVKT Math. And thank you for watching.